Space phenomena that would instantly kill you. Vacuum exposure. Imagine your helmet cracks. No explosion, no cinematic ripping. Space doesn't pull air out. It does something far quieter, far worse. Pressure around your body drops to zero. The air in your lungs escapes on its own. Hold your breath, and your lungs tear. Oxygen stops reaching your brain. Vision narrows. Sounds fade. Consciousness slips away. Your blood stays inside, but saliva on your tongue boils. Moisture on your eyes vaporizes. A thin foam might form at your lips. Tiny bubbles from your own fluids. Your body swells slightly, not from violence, from nothing pressing back. No pain at first, just confusion, then blackout. 15 seconds and you're gone. Not frozen, not torn apart, just quietly switched off. Micrometeorites at insane speeds. You'd never see it coming. Space is full of dust, grains smaller than sand, harmless until they move. In orbit, micrometeorites travel faster than a rifle bullet. Some hit at 20 to 70 kilometers per second. At that speed, size stops mattering. A grain of dust hits like an explosive. No warning flash, no sound, no time to react. The energy is so extreme the particle vaporizes on contact, and so does part of whatever it hits. Metal doesn't just crack, it flashes into plasma. Space stations aren't punctured. They're slowly sandblasted by invisible bullets. That's why spacecraft use layered shields, not to stop the dust, but to make it explode before it reaches you. Out there, danger isn't big. It's microscopic, and it's moving fast enough to turn emptiness into a firing range. Cosmic rays passing through you. You're being hit right now. Not by light, not by radiation you can feel, by particles from exploding stars. Cosmic rays are atomic fragments accelerated to near light speed by supernovae and black holes. They don't bounce. They don't slow down. They pass straight through you. Every second, particles from deep space punch through your skin, your organs, even your DNA. Most of the time, you never notice. They slice through cells, snap molecules, then keep going, gone forever. But sometimes they hit the wrong place. A single cosmic ray can flip a bit in your DNA, scramble a neuron, trigger a mutation that won't show up for years. On Earth, the atmosphere protects us. In space, that shield is gone. Astronauts don't just age faster. They accumulate invisible damage, one particle at a time. You don't feel cosmic rays. You don't see them. You don't hear them. But they reveal something uncomfortable. The universe is constantly passing through you, and it doesn't care what it leaves behind. Solar flares and radiation storms. The sun feels safe, warm, predictable. It isn't. Sometimes the sun snaps. A solar flare erupts, releasing more energy in seconds than humanity has used in its entire history. Along with light comes radiation. A storm of charged particles launched straight into space. On Earth, we're protected. The atmosphere absorbs it. The magnetic field deflects it. But without that shield, those particles tear through the body. Cells malfunction. DNA fractures. The nervous system overloads. In open space, a strong solar radiation storm can deliver a lethal dose in minutes. No warning, no explosion, just invisible damage stacking faster than your body can repair it. That's why astronauts track the sun constantly. Because a single flare at the wrong moment means nowhere to hide. The same star that keeps you alive can cook you from the inside out. No fire, no sound, just radiation quietly rewriting your cells. Neutron star gravity. A neutron star looks small, almost harmless. It isn't. This thing packs more mass than the sun into a sphere the size of a city. Get too close. And gravity doesn't just pull you down, it pulls you unevenly. Your feet feel it first. They're closer. So gravity there is stronger. Blood rushes downward. Bones compress. Your body stretches vertically while being crushed from the sides. This isn't falling, it's tidal tearing. But then it gets worse. Neutron star gravity is so intense that normal matter stops behaving normally. Atoms are forced closer than they were ever meant to be. Electron clouds collapse. Chemical bonds mean nothing. Your body stops being biology and starts being raw matter under extreme pressure. You wouldn't splatter, you wouldn't explode, you'd be flattened. A human body compressed thinner and denser than anything that can survive being human. No pain you can register, no final moment. Just gravity turning a person into a physics limit. Spaghettification near a black hole. Black holes look mysterious from far away. Up close, they're a nightmare. Fall toward one, feet first. Gravity at your toes is stronger than at your head. The difference isn't subtle, it's astronomical. Your body starts to stretch, not all at once, gradually. Arms, legs, torso, pulled longer and longer by gravity that doesn't agree with itself. This isn't an explosion. It's precise, mechanical, unavoidable. Physicists call it spaghettification. Tidal forces stretch you lengthwise while crushing you sideways. Every atom feels a different pull. Your body can't stay together because gravity won't let it. Long before you reach the black hole's edge, you're already gone. No fire, no flash, no final impact, just matter being stretched thinner and thinner until you is no longer a shape, just a direction. The universe doesn't tear you apart violently. It pulls you until there's nothing left to pull together. Gamma ray bursts. Gamma ray bursts are the universe's deadliest flashlights. Somewhere in the cosmos, a massive star collapses, or two neutron stars collide, and in seconds they release more energy than the sun will produce in its entire lifetime. That energy doesn't spread out, it fires in a narrow beam. Point that beam at a planet, and the atmosphere is stripped apart. Ozone layer, gone. Radiation shield, gone. The surface is flooded with lethal gamma rays. DNA shatters, cells fail, ecosystems collapse in moments. Even from thousands of light years away, the beam is strong enough to sterilize an entire world. The burst only lasts seconds, but there's no buildup, no flash to react to, no time to hide. One moment, the planet is alive. The next, it's a silent rock orbiting a star that never knew what happened. No explosion, no warning. Just a cosmic spotlight passing over the wrong place and erasing it. Supernova shockwaves. A supernova is a star dying in a spectacular explosion. From light years away, it looks beautiful. A new star appearing in the sky, a cosmic firework. But that light is just the announcement. The real danger comes later. When a star explodes, it launches a shockwave, a wall of high-energy particles, radiation, and pressure, racing outward at thousands of kilometers per second. If that wave reaches a planet, it doesn't politely arrive. It slams. Atmospheres are stripped away. Magnetic fields collapse. Radiation floods the surface. Life doesn't burn. It breaks. Cells fail. Ecosystems unravel. Anything exposed is slowly erased. And here's the worst part. You don't see it coming. There's no flash in the sky, no warning sign. One day, everything is normal. Days, months, or years later, the wave arrives. A supernova doesn't kill instantly. It poisons a world after the explosion is already over. From far away, a beautiful new star. Up close, a delayed sentence carried across space. The universe doesn't rush extinction, it just schedules it. Quasars brighter than entire galaxies. Quasars are not stars. They're what happens when a supermassive black hole starts eating aggressively. At the center of some galaxies, a black hole pulls in gas and dust so fast that the material heats up to millions of degrees before it ever crosses the event horizon. That glowing disk releases more energy than billions of stars combined. Not metaphorically, literally. Imagine one point in space outshining your entire galaxy. From millions of light years away, a quasar is just a bright dot, a cosmic lighthouse. But up close, the radiation would strip atoms apart. Atmospheres wouldn't burn. They'd be blown away. Molecules wouldn't melt. They'd be torn into plasma. Planets wouldn't get time to react. Life wouldn't get time to fail. Everything would be erased by raw energy flooding the system. And here's the unsettling part. All of that power comes from something that doesn't shine at all. A black hole. Invisible. Silent. Surrounded by light so violent it can dominate an entire galaxy. A single feeding black hole. Louder than billions of suns. That's not brightness. That's scale breaking. Hypervelocity stars. Most stars live boring lives. They orbit the center of their galaxy, locked into predictable paths, mindlessly circling for billions of years. But some stars get kicked out, too close to a supermassive black hole, too close to the wrong interaction, and suddenly, they're flung away, not drifting, not wandering, launched at millions of kilometers per hour. These are hypervelocity stars, fast enough to escape their own galaxy. And here's the problem. A star doesn't need to hit you to destroy you. If one passes through a solar system, its gravity rewrites everything. Planetary orbits stretch, then tilt, then snap. Worlds get ripped from their stars. Some are flung into deep space. Others spiral inward and burn. No explosion, no warning, just gravity rearranging the system faster than physics can stabilize it. From the outside, nothing dramatic happens. One star passes, another keeps going. But inside that system, every clock is broken, every orbit erased, every world lost. A hypervelocity star is not a collision. It's a drive-by gravity crime, a celestial bullet that doesn't need to touch you, because gravity always reaches first. Thanks for watching. Don't forget to subscribe, and we'll see you in the next one.